So Studio One is the design, implementation, and the testing of a 2-bit comparator. So here is a black box in which you have to essentially design your 2-bit comparator. So if you're comparing two numbers, I'm essentially saying that use 2 bits AB to represent the number n1. A and B are both binary variables, so each of them could take a value of 0 or 1. And for the next number, because we need something to compare by something else, for the next number CD, C and D are again binary variables, so each of them could take 0 or 1. CD represents another number n2 in decimal. So just so that we are all on the same page, if A is 1 and B is 0 and C is 1 and D is 1, N1 is going to be what? A is the most significant bit here, B is the least significant bit here, so it's going to be 1, 0 in binary, which is what? 2 in decimal. And similarly, N2 is going to be 1, 1 in binary, which is 3 in decimal. So for this particular case, I'm going to expect that AB is not greater than CD, AB is not equal to CD, AB is actually less than CD. So this is a quick conversation about how the comparator for one particular case of inputs, and again, this is a 4-bit input, so there is 16 possibilities here. I'm just showing you one possibility. And what is the bare bone discussion of 2-bit comparator. I would encourage you guys to spend some time to read. It's a 3-page document. It's not much, but I would encourage you guys to read it so that you get all the details. Now, if in my design, once I do the design, implement, and when I test it, I would want to create an XDC file, the Xilinx design constraints file. XDC. Why do you write that file? You write that file so that you can map each input and output to something that is physically present on that BASYS 3 board. So you need to map that. My design, I'm calling this A, B, C, and D. AB greater than CD, AB equals CD, AB less than CD. So for all those 7 things, 4 of them input, 3 of them output, I need to map them to something physical like a LED or a slide switch on the BASYS 3 board. There is a question on chat box. Let me answer that. Do we only need one constraints file? Yes, absolutely. No matter how many design VHDL files you write, you will only write one constraints file in which you will talk about all the mappings of all inputs and outputs to something physical on the board. There is one board, which means there is one Xilinx design constraints file. So it's essentially used to map. Let me write this. Map all inputs and outputs to FPGA pins. As you know, the BASYS 3 board has an FPGA right in the middle of the board. It has a lot of those pins are connected or are wired to slide switches, push buttons, LEDs, and so on. The same way, you can think of it as your brain connected to your fingers, right? They are things that are connecting your brain to a finger. That is the mapping that we are talking about in terms of XDC. So you need to explicitly mention what is A connected to, what is B connected to, which pin on the FPGA are they connected to, and so on. Let's see, there's another question. Will I lose points if I wrote 3 separate ones? Uh, I'm not sure if I'm understanding correctly. There is,
When I was going through, I thought from like the Studio Zero instructions when it created the AND gate
yes.
XDC file, I interpreted it as I have to create an XDC file for every operate for like every comparison I'm doing, like for the and if they're equal, if they're greater than or less than. So I created three separate XDC files.
Uh, well,
I assigned the correct LEDs to each one, so it still worked for me. Like I
ye-
tested all 16 combinations, they all work.
right. So, so here, I would say this. Um, Even though it works and you're able to get it to work for now,
Hmm.
the fact that you have 7 things, you were able to probably create 7 files and you got away with it. But in the future, as the studios get more and more complex, you might have 40 lines, right? 40 things to connect. So it will become impossible for you to make 40 files.
Okay. Yeah.
So, for now it's okay, but for the future, I would say put everything in one file. That is going to be
Uh,
your Xilinx design file for the entire design. So think of it like this. Think of it as you have, oh, come on. Let me do this in a better way. You have component 1, you have component 2, you have component 3, you have component 4, you have several components inside a main design, right? We call that top level design. So whatever you are looking at, oh, as the input and the output to the top level design, those will need to be connected to something physical in the XDC file. In this case, only 5 of them, right? So
yeah.
no matter what you have inside of this top level, there might be 100 design files, right? In this case, we are showing one VHDL file, two, three, four, five VHDL files, and the sixth one is the top level VHDL file, which puts the 5 of them together. But in total, there is only one XDC file which talks about the main 3 inputs and 2 outputs. Um,
Okay.
so for now it's okay, but for later on, I would encourage you to deal with it, as suggested. All the constraints in one file.
Okay.
All right, let's move on here. You guys must have read this at some stage that the VHDL any VHDL code will have, well, any VHDL code will have 3 things. I don't want to say 2 things. Any VHDL code will have 3 things or 3 sections. Sections is probably better. The first section is going to be the use library IEEE 1164.all. The statements right at the top of, I want to say that in terms of syntax, I might be wrong, but I just want you to know that there will be a few statements right at the top of the VHDL file which are going to import those IEEE standards that essentially have all the definitions of the keywords that you will use in your VHDL file. So, for example, if you say entity or architecture or and or not, that library will have the definition of all those words that you are going to use inside your VHDL file. So the first thing that you do is to say I'm going to use this particular standard. It is, when you are doing the entity wizard, those statements are written for you, so you don't have to worry about that. But that's the first section. This is something similar to when you're writing a C code, you do hash include stdio.h, right? And then you will include other things, but this particular statement is similar to that. The next part is the entity part. And the last part is architecture. What do you do in entity? You talk about what are the inputs and outputs. What are the inputs and outputs to your design? In our case, we are going to say my inputs are, let's see, my inputs are A, B, C, D. My output is, my outputs are A, B, GT, CD, AB equals CD, AB less than CD. So I need to talk about, 7 things over here. Note, each one of them is 1 bit right now. It's not a bus or a vector. It is all 1 bit. So you're going to use the wizard that you used in the previous studio, and you create a new entity by saying A, B, C, and D are 1 bit inputs, and there are 3 corresponding 1 bit outputs. So that's what entity does, right? It just talks about what is here. What are the inputs and what are the outputs? It doesn't talk about what is inside. So who talks about what is inside? Well, the architecture, right? So the architecture is where the designer needs to describe what is inside that entity, the black box, or the relationship between input and output, which can be done using logic expressions. So let me talk about that in just a bit. You start with the table. A, B, C, and D are 4-bit binary variables. As in, A is 1-bit binary variable, B is another binary variable of 1 bit, and so on. So in total, they are 4 bits, which means there are 16 combinations. They start with 0, 0, 0, 0. Alternates 0, 0, 1, 1, 0, 0, 1, 1, 4 zeros, 4 ones, 8 zeros, 8 ones, and so on. And the last one will be 1, 1, 1, 1. 16 possibilities. Once you have that, then for each particular row, you will find out whether AB is greater than CD or equal to CD or less than CD. These outputs are mutually exclusive, which means that if one of them is 1, the other two have to be 0. So for the first one, what do you have? AB is 0, 0, CD is 0, 0, which means AB equals CD. Similarly, for the next one, CD is greater, so AB is less than CD. For the next one, still this guy, and you would fill out the entire thing. For the last one, you would get equal. Once you have this, then for each particular entry, you would write a corresponding, so you would write a logic expression for this, this, and this. 3 logic expressions. And the keywords that you can use are listed over here. So I want to talk about how would you do it for example, AB equals CD, right? So let me do that for the middle one. it is going to be 1 here. It is also going to be 1 here. And at 2 other places, it will be 1, right? So where are those 2 places? There is going to be a 0, 1, 0, 1. Where is that going to be? Let's see. It is going to be right here. And then the last one will be 1, 0, 1, 0. So 1, 0, 1, 0 is 10. 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For that also you're going. So that there are only going to be 4 spots in which AB is going to equal CD. Other ones will be 0. So you only have to focus on that, and that. So what would be the expression here? Well, if I go back, let's see. AB equal CD, signal assignment operator, less than and then equal to. That's the signal assignment operator. The first place where it is 1 is when A is 0, B is 0, C is 0, and D is 0. Which means I write not A and not B, not C, not D. And. This and this and this and this. And all of this I can put in parentheses. Or next one. What do I have? 0, 1, 0, 1. Okay. So not A and B. I don't even need parentheses there. Not A and B. Next one is what? And not C and D. Similarly, you get another OR, and then you have A and not B there, and then you get OR, A, B, C, A and B and C and D, and then semicolon. So you would get 4 entries in this, one for each location where it is 1. Similarly, you would have to do that for AB greater than CD and AB less than CD. So signal assignment operator, output over here, inputs, a relationship between the inputs over on the right side, and the statement with a semicolon. And then you would have to do a constraints file where the Xilinx constraint file. Once you are done with this, save your design. You can do a design rule check, the DRC, and then use A, B, and C, D as your switches. And the outputs, you can put them to LEDs. You can map them in your Xilinx design file to LEDs, and then run through all the 16 possibilities and check whether the LEDs are lighting up correctly or not. Now, so that's essentially what the studio is. Let me answer a few questions that I see on the chat box. The question is this hard coding the answers? No. So this, you're not hard coding the answers, right? You're literally forming the logic expressions first. And you're forming the logic expression based on the entries in the table. So in your design steps, the first step of the design is to be able to fill out this particular truth table, which is based on the design criteria, 2-bit comparator. Once you have this truth table filled out, you would then convert this into logic expressions. So you would develop logic expressions, one for each output. So you would have 3 statements. I just showed you one statement, at least the basics, most of the first statement for AB equals CD. Now, some of you might have other ways of doing this which are more efficient if you are but that's up to you. I leave that as a choice. If you have if you know some simplification strategies from before, you can do that simplification. However, this is how you would do it by working using logic expression. This is not hard coding the answers whatsoever, because you're relating expressions, right? So A could be 0 or 1, B could be 0 or 1, and so on. Let's see. The next question is, do we have to code all the assignments on one line? No, you can I think you can split it up into multiple. There is going to be a variable less than or equal to, which is the signal assignment operator, followed by you can wrap statements one below the other. You don't have to do it in one line. All right, other questions, guys? And then make sure that there is a Studio One write-up. It's not going to be time consuming. It is supposed to be very straightforward, where you provide the logic expressions which were part of your design. You provide the VHDL code separately. You provide the XTC file separately, and then you explain how you tested your design. The TAs will be doing a checkoff where you have to show that your design actually works, but make sure that you check for all the 16 cases. And then I would also like to learn from your experience. So please provide that as well. So in total, it's a 25-point submission there. Okay, so let me stop this recording and